Hi everyone, Mrs. Bilo here. In this video I'm going to be continuing in the Chapter 3 notes, now talking about isotope and hyphen notation and how to write that. So isotope notation, as the name suggests, this is the format we're going to use to write formulas for elements that are isotopes. And also, this information just tells us more about the element itself. Okay, what element is it? What is its mass? And does it have a charge or not? So right here will be the element's chemical symbol. For example, carbon was C. The number that will go here as a subscript on the left-hand side of that chemical symbol will be the number of protons, also known as the atomic number. So the number that you're getting from that whole number, you're getting from the periodic table. And then here, because we're talking about an individual element, will be the atomic mass, and that will be from adding the protons and neutrons together. And then I didn't put it here, but here would be the charge. So if there is no charge, the atom is neutral, then you don't write anything there. But if you do have a positive or negative charge, that's where it would go, and that's a superscript. So let's do an example. Here's just information, okay, about how to find the stuff you need for isotope notation. And then just to briefly mention hyphen notation, this is basically known as a shorthand notation, so it doesn't give you as much information as isotope notation would. It does tell you if it's an isotope or not, but it doesn't tell you anything about the charge. So the format is the name of the element. So like, let's say carbon, for example, dash, and then the mass, which is protons plus neutrons. So like carbon 13. So that's an isotope for carbon because it's a little bit heavier. And it doesn't tell us anything about the charge. Just assume that these are neutral. All right, so let's do a few example problems. So number 1, we have nitrogen with 7 protons, 8 neutrons, and 7 electrons. So nitrogen on the periodic table is right here. It has the chemical symbol N. Now, if I didn't give you that information, so let's say I didn't tell you what the element was, another way to figure that out would be the number of protons. It says 7 protons. If you look on the periodic table, nitrogen has the atomic number 7. And that number, the number of, I'm going to try to color code here, the number of protons will always be written here as a subscript on the left-hand side of that chemical symbol. So we always put the atomic number here, which is also the same as the number of protons. So I always like to start here. I start with this, okay? What's my element and what's its atomic number or number of protons? Next, I'm going to figure out the mass. So remember, the mass is going to be the protons plus the neutrons. So we're going to do 7 plus 8, which is 15. And that number is going to go here. So that is the mass, the atomic mass, which is protons plus neutrons. And I already knew what the protons were because of the element that it is. And I already knew, and then it told me the number of neutrons. So I added them together. Last, we have the charge, which is, in this case, it's neutral. So I know that because, so protons, right, those have a positive charge, and electrons have a negative charge. Since you have, these are equal, this atom would be neutral. You have the same amount of pluses, protons, that have a positive charge, and the same amount of minuses, electrons, which have a negative charge. So they would cancel each other out, and you don't write anything here. You just leave it blank because there is no charge on it. So go ahead and pause this video and try to do question number 2. All right, now I'm going to go over question number 2. Again, this element is potassium, but if I didn't tell you that, you could just look on the periodic table. for the atomic number 19, because that is the number of protons. Remember, the number of protons, that's the same as the atomic number, which is that whole number on the periodic table. So potassium is right here. It's atomic number 19, and its symbol is K. So P is for phosphorus, not potassium. And then next, I know my number of protons, because again, that I'm getting that from the periodic table. The question is also telling me that. And then we have our mass, which again is protons plus neutrons. So 19 plus 20, which is 39. And then lastly, for this problem, we had a neutral charge, so we didn't have anything here. So we have 19 and 19. So I have another example where I'll show you what it looks like with a charge. But let's say, hypothetically, if this was 18 electrons. Okay, so let's do this problem as if it does have a charge, because this is no charge because these two numbers are the same, the electrons and protons. Let's go ahead and change this to 19. So now if I have 18, if I have 19 protons and 18 electrons, these are not the same. And it looks like I have one more proton, so there's 19, than I do electrons. So I have one more positive charge than I do negative charge. So the charge on this would be +1. It's a plus because we have more protons, and it's +1 because we have one more proton than we do electrons. All right, let's do some other examples. So in isotope notation, write iodine with 73 neutrons and 54 electrons. So this question is telling me the identity of the element, which is iodine. Okay, and if I look for iodine on my periodic table, it is right here. And iodine has the atomic number 53. So first, that's my chemical symbol. The question didn't tell me the number of protons, but that's okay because I know the identity of the element. I can find that on my periodic table, and that tells me the number of protons, which in this case is 53. That whole number, the atomic number. And that's going to go right here. Again, if I told you the number of protons, you can figure out the element on the periodic table. If I told you the element, then you can figure out the number of protons by looking on the periodic table. Next, we're going to calculate the mass, which again is protons plus neutrons. So 53 plus 73. Oops. Let's see, 53 plus 73 is 126. Again, that number goes there. Again, that's protons plus neutrons. And then we have to look at the charge. So it looks like we have 53, right? This is the number of protons, the atomic number. So we have 53 pluses, and we have 54 electrons or minuses. So it looks like we have one more electron than we do protons. So this would have a negative charge because we have more electrons than protons. And it's going to be a charge of -1 because there's one more electron in comparison to protons. For the next problem, we're doing it in reverse. So I'm giving you the isotope notation, and then you're figuring out the protons, neutrons, and the number of electrons. Let's go ahead and do that. So right away, the number of protons, it is right here. It is 4. You could also check on the periodic table. Be, which is beryllium, is right here. And you can see that it is atomic number 4. Next, we have our neutrons. So you do have to think a little bit. So this right here, remember, is the mass, which is your protons and neutrons added together. So if you want to just find the neutrons, well, you know what the total mass is. The total mass is 9, which is protons and neutrons added together. You can subtract out the protons to find your number of neutrons. And that makes sense because if you added these two together, that would give you your atomic mass, right? That's protons plus neutrons. So you do have to do a little bit of deduction to figure that out. And then for our electrons, so for this one, it looks like we have 4 protons, right? Because that's our atomic number, okay? That's the number of protons. And it looks like our charge is +2. So if we want to have a charge of +2, that means we have 2 more protons than we do electrons. So for the electrons, we must have 2 electrons, because if we have 2 electrons, that means that we have 2 more protons in comparison to our electrons, which is going to give us that 2 plus charge. I don't care about the format personally. You're supposed to write it like 2 plus or like 1 minus. I don't care. Just -1 is fine. That's how I do it. And then for the electrons, we would have 2 electrons because you have to have 2 more protons than you do electrons because we have a charge of +2. All right, let's do 2 more examples, okay? These do not have charges on them. I'm gonna actually go ahead and throw a charge on this guy just for some practice. All right, so for question 1 here, so we need to find the protons, neutrons, and the number of electrons. All right, so right away, the number of protons is 6. That is this number right here, which makes sense because carbon on the periodic table, its atomic number is 6. And then neutrons, again, remember, this is the mass, which is protons and neutrons added together. So if you want to just find the neutrons, you have to take that mass, which is the protons and neutrons added together, and subtract out the protons so that you can just find the number of neutrons. And that makes sense because if you add 6 and 7 together, that would be 13, which is your mass. For this particular example, there is no charge. So to determine the number of electrons, so we know that there's 6 protons, right? That's the atomic number. So if we want to have no charge, that means we would have to have an equal number of electrons so they would cancel each other out. So this particular example would have 6 electrons. Go ahead and try the next problem on your own and see if you can figure that out. So pause the video and see if you can figure that out. All right, now I'm going to go ahead and go over that. So protons, you should have gotten 16. That's this number right here. Neutrons, remember, again, this is the mass, which is protons and neutrons added together. So I would do 31 minus 16, which is 15. So that's my number of neutrons, because if you add 16 and 15, that would be 31. Now the electrons are a little bit more tricky. We know for sure that we have 16 protons, and the overall charge is -2. So that means we have to have 18 electrons because we need to have a charge of -2. So we need to have 2 more negatives, 2 more electrons than we do positives. So we would have 18 electrons and 16 protons to give us a charge of -2.